Good morning, it's me, Mr. Trewen, back again for another lesson in geometry. Today we're going to be going over part 2 of parallelograms, where we're going to focus on the rhombus, the rectangle, and the square. Now in the previous video I did not go over that so much because it was too much information at once. What I did go over with you was that on a parallelogram, and remember that's our symbol, on parallelograms the opposite angles are always congruent, the opposite sides are always congruent, and the diagonals always bisect. Now, we're going to go over 3 shapes. Now, each one of these shapes has a little bit more, we add another characteristic to it. So the first one we're going to look at is called a rhombus, which is a quadrilateral that has 4 congruent sides. All sides are the same. And no, this isn't called a diamond because this ain't a Mickey Mouse Club. It's called a rhombus, 4 congruent sides. Now, the thing about a rhombus is when it comes to the diagonals, when you have a diagonal, when they cross or they intersect, they form 90 degrees. They're perpendicular at the diagonal. Now, when it comes to the next shape called a rectangle, now we have a quadrilateral with 4 congruent angles. Well, since there's 360 degrees, and if you divide that with 4, they always end up being 90 degrees. So we have 4 right angles. But again, the definition is 4 congruent angles, but they are going to be right angles. And the thing about their diagonals are, when you have the diagonal from here to here, and from here to here, those diagonals are always congruent. And since they're congruent and they bisect, we know that all the diagonals can be broken into smaller pieces that are all the same. Now, the last one that we're going to go over with in the parallelogram group is a square. A square has all the characteristics of a rhombus because it has 4 congruent sides, all the characteristics of a rectangle because it has 4 right angles and 4 congruent angles. So when it comes to the diagonals here, we know that 2 things are going to happen. First off, they are going to be congruent in length. And second, all the diagonals are going to be right angles. They're all going to be perpendicular. So we're going to end up with right angles there. All right, so our first example, we have example 1. I have not written the names because I want you to focus on looking at the shape and figuring out what it is and then taking it from there. But the first one, when I look at it, I see 4 congruent sides. So this should tell us that this is a rhombus. Now, I've asked you to figure out all of these different variables, which I guess I could have just wrote in solve all the angles. But when we look at this, remember, break things up. Let's not focus on the whole thing at once. Let's just focus on maybe a half of it. You see how this side and this side are the same? We have, if we only focus on this half, we have an isosceles triangle, which means if you start with 180 and you minus 50, you have 130. Think about that. It's isosceles, which means that both of these have to be the same number. They both have to be 65. Okay, and so the other thing we know is because it's a parallelogram, we know that if this side down here, down in this corner is 50, the opposite angle is also 50, which means these are all going to be the same. And then if you put that together, you have 130 here, and then the opposite angle would be 130. So remember, sometimes it's going to be best to break this shape down into smaller pieces. All right, number 2, looking at this. Once again, what shape is it? And then we take it from there. So when I look at it, looking at it as a whole, trying to not get bogged down with all the different lines. On the outside, going along the perimeter, I see 1, 2, 3, 4 congruent marks. This is a rhombus. I know it's not a square because I don't have right angles and I don't have congruent angles. All right, so working with that and working with these diagonals here, I can start to take this problem and break it down into smaller pieces. The first thing I know about this is the diagonals are perpendicular. So right away I can fill in 90, 90, 90, and 90. This changes everything. The problem just got a lot easier because I know the diagonals are perpendicular. With that being said, start in anywhere. I'll start here because I see I have two values, and I look at this and maybe break this apart. Just use one triangle. Knowing this is 90, knowing this is 60, I can figure this out very quickly, because 180 minus 90 minus 60 tells me that this angle right here is 30. And think back to what we just did. A rhombus is just two isosceles triangles back to back. So once I know that's 30, things go very quickly. This is 30, this is 60, this is 60, this is 60, 30, and 30. So again, it all starts with just knowing one of the characteristics that gets your foot in the door, and then you can take off from there. All right, let's move on to number 3. And like I said, this can be a little bit of a shorter video because I think we covered the bulk of the material in the first video. And this is kind of getting very specific about these 3 shapes. All right, so number 3. Before I get started, I need to know what shape it is. So taking a look at it, I don't see any marks along the outside, which is telling me this isn't a rectangle, or this isn't a rhombus, because it would have to have 4 of the same side. Now I do see 4 right angles, which is telling me that they have 4 congruent angles, but it doesn't have 4 congruent sides. It's a rectangle. And I know that most of you already know that. But knowing that it's a rectangle, things can happen really quickly when it comes to solving, because with these 90 degrees here in the corner, for each corner of this rectangle, I already know some of the numbers. I also know that because it's a rectangle, the diagonals are congruent, which means this is equal to this, just like all of these are the same. Well, think about that as maybe a way to break this down and do a smaller item. What are you looking at? An isosceles triangle. That's why if this is 20, this is 20, and this is 140. It happens that quickly because I know that in an isosceles, these two have to match, and they make 40. And triangles make 180, so that's 140. Well, we learned way back at the very beginning of the year that if this is 140, a vertical angle is also going to be 140. I can figure this one out right next to it. Even though I didn't put a letter there, I do want to go over the fact that if this is 140, this has to be 40. We have to have a linear pair. They got to make 180. So this is 40, which tells me over here, what would this be? 180 minus 40, 140, divided in half, and you've got 70 and 70. 70, 70, 20, 20. Everything fills in very quickly if you recognize that this is an isosceles triangle and it's just 4 triangles put together. Break it apart, break down one piece, and you can fill in all the others. All right, our last shape that we're going to look at is example 4, and I forgot to write the information I wanted to write on it, so I'm going to do it now. I forgot beforehand, oh well. Anyways, when I look at this, if I see 4 sides that are congruent, it's got to be a rhombus or it's got to be a square. But when I look closer, I see 4 right angles telling me, hey, this is a square. With that being said, I can now break it down. I want to figure out some of these angles. Well, remember, on a square, the diagonals are perpendicular, which means right here in the middle, 90, 90, 90, 90. I also know that the diagonals are congruent. So when I do that, I can see that it's really just 4 isosceles triangles all connected together. And if I'm having a hard time looking at all this, maybe break apart, take one of them out, and then break it down. Triangles make 180, so 180 minus 90 gives me 90. Divide that by 2, and I have 45 and 45. So I know that this is 45 and 45. Well, I'm not going to write every single one of these in here, but I think you would know that this is 45, 45, 45, all the way around. Okay, and the last thing we know about a square is that all sides are the same. So if I want to figure out what the value of x is, all I got to do is set this one equal to this one, and I'm good to go. So 3x minus 3, x plus 7. Again, variables on both sides. Take the smaller. 2x minus 3 is 7. Add your 3. 2x is 10. X is 5. Don't forget to always plug your answer in. So if I know that this is 5, 3 times 5 is 15. Take away 3. This is 12, which means this is 12, this is 12, and this is 12. So we take one thing, plug it in, and we get everything. All right, well, I hope this helps, and I hope this has this all figured out for you. And that's it. Bye.